name's Justin Block. This is Matt Martin, Alex DeLello, Casey Hill. We're here at WVU Sustainable House demonstrating our senior design project. We like to call this project the Power Management and Control System. For a quick overview of the project, we're going to throw it over to Casey.
Okay, so basically we have three main goals for this project. The first is to eliminate homeowners' ignorance with their home appliances. We allow them to know exactly how much power each appliance is using. Secondly, we want to give them the ability to manually and automatically control the appliances in their home on a schedule and based around dependencies that they get to choose. And third, we want to inform them based on each appliance how much each appliance is going to cost them per month on their power bill. So we simulate data being fed into our system from a power provider, and using the data drawn from each appliance, calculate how much each appliance is going to cost you on your monthly power bill. So Thad is going to talk about our interconnect, the main hardware piece of the project.
Okay, the interconnect plugs into the wall. The appliance plugs into the interconnect. The interconnect can switch the device on and off, monitors voltage and current instantaneously, and has a temperature sensor. The wireless sensor node is this piece here, which has a high resolution A to D and D to A and wireless networking. This board is a sensor board from a kilowatt. Solid state relay is down there, although you can't see it very well. And this board is basically an interface between those components.
Alright, so as Thad previously mentioned, in each interconnect we actually have the Telos B mote, and here's actually an up close of it right here. This is actually our base station, which the base station can send out packets to all the different modes that are sitting in our interconnect and can send commands to them, tell them turn on, turn off. And then this guy actually can receive packets that contain voltage, current, temperature, and receives it, and then it comes in here and actually goes into a Linux virtual machine, because the Telos B mote uses TinyOS, which is BSD license, so it comes straight into the virtual machine, which the data is later exported out through TCP to the software.
So as Alex was mentioning, we send the packets to our C# based software. This C# based software has multiple abilities. First, you have the ability to view the data graphically. This data can be viewed per device, so you can change the device. We have a desk lamp, refrigerator, and standing lamp. It can be viewed based off of what value you want to look at, such as voltage, current, power, temperature. And finally, you have kilowatt hours, the amount of power you've used over the last hour, plus the cost. The cost is determined through our simulation program, which in areas where power loads are high, the kilowatt hour cost price actually changes based on the time of day when people use the most electricity, and the time of year, such as summer, when people use more electricity than in the winter. This creates a price. Right now we have it set as 11 cents, which is pretty high for West Virginia, but something that could be common in, say, Europe. And then this comes through, and then you can see the cost. You can view the estimate of your power bill for that device. Here we can see it's $13 over the last month. You can change the time span in which you're viewing. Right now we have the last minute, the last day, last week, and the last month. Now this project gets its real strength out of the switching and dependency abilities that we have in this program. You have 4 different dependencies you can do. First, you can determine if the person can manually switch it on or off. Second, you have a temperature dependency, something that's important for, say, refrigerators. A refrigerator, you turn it off when it gets too cold, and then you turn it back on once it warms back up, so it stays between a certain range. You have a time dependency, such as an alarm clock. You say you leave your light on, you tend to leave your lights on 11 p.m. when you go to bed. or 12 p.m., and then it automatically will turn it off. Then in the morning, when you wake up at 9 in the morning, you will turn it back on automatically. And also you have a kilowatt cost dependency for when the cost is too high, then you automatically turn it off. And finally, in this project, as I was mentioned, you can switch it manually. So I'm going to give a demonstration of it switching manually. So if you can look at the lamp over here, we're going to send through a switch. It's off. Switch again. On. And that is our project and a demo of how it works.